Hello everyone and welcome to ABB RobotStudio tutorials. In this tutorial we explain how to add robots to the workspace and how to visualize robot work envelopes as well as the active tool envelopes. Furthermore, we will explain how to add, or better to say, how to attach end effectors or grippers or even tools to our robots. What you can see over here are two ABB robots. And these green clouds around these robots are actual work envelopes. The knowledge of work envelope is very important in estimating the performance of the robot as well as designing robotic tasks. Namely, we would always like to put a workpiece or a work object around the actual inside of the envelope such that the robot can reach a work object or a workpiece. That's why it's very important to know very precisely the work envelope as well as the active tool envelope. Okay, let's immediately start. Once you open RobotStudio, you will see this main screen. If you don't see this main screen, you need to click on New. Then click on Project, and over here we're going to create a new project. Don't click on Include a Robot in Virtual Controller. Just click on Create. Later on, we will include a robot and virtual controller. Okay, so this is our empty workspace. Let's add the first robot. To add the first robot, click over here and select the robot. I will select IRB 120. And let's use the default settings. Here it is. Now, next we need to learn how to zoom, how to rotate, and how to pan the view. To zoom the view, we simply use the middle mouse button, which is actually a roller button. Just roll it forward and backward and you can zoom. Or you can press it, that is, press the middle mouse button and move the mouse left or right. Then, to rotate, press and hold Ctrl, Shift, and left mouse key and then move mouse left or right. Again, Ctrl, Shift, left mouse key, move left and right. And then finally, to pan the view, that is to move the view, press Ctrl, hold the left mouse button and move left and right. Okay, next, let's add the virtual controller. Click over here and click from Layout, click on Next, and click on Finish. Here you should be patient, it will take some time. Now over here you can see the controller status. Currently it's red, this means that you cannot use the controller. However, once it becomes green, you can use it. Okay, to move this robot you simply have to click over here and then you can select the joint that you want to move and then use the mouse button to move it. Simple as that. Okay, next, let's add a tool to this robot. So to add the tool, click on Import Library, and over here you have several options. You have a smart gripper for this robot, or you have the training objects. Over here I will use this training object called My Tool, and here it is. It's a contour and represented over here. And notice that the tool is placed at the center of the world coordinate system or the base coordinate system, if they match each other. Okay, the next thing is to attach the tool to this plate over here. To do that, click here on Tool, do the right click, and then scroll all the way down, and you will see Attach To, and then simply attach the tool to the robot. And click on Yes, since you want to update the position of My Tool, and here's the tool. Okay, so this is our first robot. Let's add the second robot. To add the second robot, we follow the same procedure. Click over here, click on the robot you want to add, click OK, and here's the second robot. Next, let's move that robot. To move that robot, simply click over here, and let's translate the robot. Oops, I made an error, so I will deselect this move. I will again select the robot. You can do it like this by clicking over here, then clicking Move and Rotate. So now make sure that you select this arrow, and here's how you can move the robot. So let's move it here. Then let's move it a little bit here. And you can see what happens is that these squares denoting the workspace are simply expanding as you move the robot. Okay, so let's keep it here and let's rotate the robot. So I will click over here to select everything, and then I will simply click over here and I can rotate my robot. Okay, good. Very good. Now, we can also attach a tool to this robot, and to do that we need to follow the same procedure. So let's select this robot, then import from library, and you have again several options. For example, we can use the pen. Now you can see that the pen again is attached over here. However, we want to attach it to this robot. So to do that, do the right click on pen and then scroll all the way down, attach to, and let's attach to this robot and click on yes. And you can see that the pen is over here. Here's the pen. Good. Now you can rotate and you can see both robots. The next step is to actually visualize the envelope. This is very important. Envelope represents the limits of robot motions. And by visualizing the envelope, we can actually see the limits of motion of our robot, and it also envelope is very useful for properly placing some external objects in the robot workspace. So let's see how to see. To visualize the envelope, click over here, do the right click, and then you'll need to find the option for visualizing the envelope. So let's find that option. Here it is. Show work envelope. So again, click over here, do the right click, click on the robot, do the right click, and find show the envelope. Here it is. And now what you can see over here, if I rotate, is a 2D envelope. That is, this is a cross section of the envelope. And you can see where the robot can move and where the robot cannot move. Okay. Now, here you should be very careful since this envelope is actually for this robot position. Now, here we are currently having a 2D envelope. The 2D envelope, of course, is important if everything is symmetric. However, the more information is provided by clicking over here on 3D envelope, and then this green cloud appears. Okay, the green cloud appears, and this is the 3D envelope, which is very important. However, let's try to move the robot and let's investigate if this is really an envelope of the robot. Never trust software. Always try to investigate things by yourself. So click over here to move the robot, and let's, for example, select this joint. And let's try to move the robot and let's see what happens. We can move outside of this envelope. Why is that? Why can we move outside of this envelope? Well, because this envelope is actually for the robot wrist, right? It's actually for the center point over here. And this is not the envelope for the actual active tool. That is for this thing. To see the envelope for the active tool, click over here, and then you can see the complete envelope once you add your tool. So if you try to move the robot, and whatever you're trying to do, let's try to put it to extreme position, you will see that the robot tool always stays within the envelope. And you can see it like this. In the envelope, of course, there are some points that are not reachable, and you should always be careful and always properly identify these points. Next, let's visualize the envelope for the second robot. That is for this robot. Simply select the robot, do the right click, and then search show work envelope. And then let's see the 3D envelope. Here it is. Okay, so let's try to move the robot to make sure that this is actually an envelope. And we can see it's not, right? It's not the envelope for this point. However, for the wrist joint, it is. So let's see the active tool envelope. Here it is. And this is the real envelope. And you can see already over here why envelopes are important, because by knowing the envelope, we actually know what should be the minimum distance between two robots. And this is very important.